Hello, this is another tutorial. I'm going to explain the basics of curve flow. Okay, it's related to particle systems. So basically, we're going to create particles that, in a way, follow dynamically a curve. Okay, now that's a very nice thing in order to have, like, for example, mosquito movements or birds or just blood vessels or different type of elements that move massively along a stream. No, let's see how we do that. Again, we have the machine here. I'm gonna place it on a side so I can explain the curve flow much better. And I'm gonna do a very simple cylinder. I think in class I did the example, if I remember well, with the sphere, which I thought was kind of interesting. But I'm gonna do it with the cylinder this time. I'm gonna select it and make it live. If you guys remember from old times, we could make a live object by pressing this guy. It turns into this kind of green, dark green type of color. And now whatever you draw in terms of curves, and let's make sure that we're in degree 3. It will be drawn in the object. So I'm gonna just start drawing curve that follows the cylinder. Okay. Uh, okay, we press enter when we're done. We press live again, and we can now delete the cylinder. It has helped us for the purpose that we want. It's kind of crumbly. I wish it was a little bit more dynamic, but I think you guys get the idea, so it's fine. I'm gonna select the object and make sure that I delete the history, so there's no type of history related to the deleted cylinder. So the next step is very simple. We're gonna select the curve. We're gonna go to dynamics here. Then under effects, we're gonna say create curve flow. What happens is that immediately these circles are attached to the tangency of the curve. The number of circles we could have said in the options to have more or less, and let me show you what it happens if the animation is to 500 again to make it a nice length. I'm gonna just unseen the grid so we see this better. Check the particles that will emerge that will follow the curve and will respect in terms of distance these circles. Let's see if we press play what happens. There you go. You see the particles coming up? Good. So I think we get the idea. Now why these circles? If we go back and we select one of the circles and we scale it up, this will be the space within the stream that the particles will be loosened around. Let's see if you get it by pressing against the play. Straight up, very low density, and then they collect themselves to the circle. So imagine a blood vessel. You can very easily create a model of an interior of a blood vessel, a cylinder that is deformed, and you can just create a circle a curve in the center and just variate the density of the expansion of the particle systems, and it should be a very nice way. Now obviously the blood vessels are specific objects, so that's why we want to apply our object, and if it was a blood vessel, it would be with the shape of the blood vessel. In this case we want our object to be applied to the particle, which is as simple as the instance. Now before that, I'm going to just remind what a particle is, and I explained it in the introduction to emitters, but you can pretty much go to particle shape and change many factors in terms of the shape or what we're seeing. So you can go again to spheres and have the spheres, press here to have different radius, and immediately you will have spheres instead of points following that curve. Yeah, another good way that you can control the speed, number, etc. will be in particle shapes to go up here. Sorry, and flow emitter, and say up here scale rate by speed. So now if you go down, we're in flow emitter, we go to basic emission speed attributes. We're going to be able to change the speed here and therefore the number of units. Okay, so let's make an example again. Select these guys, flow emitter, and let's say put this down and play. There you go, you have much less. You follow the curve, but they're less in number. Let's put this one. Play again. Less number. And obviously you can animate this as we know everything, so it would be right click and set key different moments. If we want even less, 0.1. Let's go back. Then less. So I think we get the idea. Let me comment this so you see the difference. There you go. Now there are many of them. Now the speed random here is pretty much that each of them, of the particles, will have a different random speed within the whole system. So okay, I think it's quite interesting. Now we need to do the last step that I also explained in the last tutorial, which is making sure we select the particles and that we have them in the shape as points, so we don't see the sphere anymore, and we select the object, shift, select the particles, and in particles we say instancer replacement. Again, the same problem we have. The objects are quite big for this system, so we just need to select the original instancer and reduce it. Okay, good. And when we play this, instead of the spheres we have our little guys. Imagine there were mosquitoes or there were anything else that you want. Let me position myself in a nice view so we see how these things are working. There they come. Now as you can see, and this is the last step that we will be seeing in future tutorials, they all have parallel position, they all have the same scale, and none of them are rotating, etc, etc. We can do that, I won't say easily, but yes, knowing 3 steps in a proper way to have a little bit more dynamism in the system. So again, this is for your next column within the grid of the presentation. So search for different curves that you can do, for example around the sphere, around different places, or up and down, and make these guys move around and search for interesting compositions within your machine. Render it with realistic quality and put it in the grid. Okay, hope you like this tutorial.